me see right now. Oh my God.
All right, if you guys can turn to page 6.
She was like, oh, she's like, that's so long. I was like,
Riley's coming. Yeah.
I pretended like I didn't check it. So.
You got any brackets? Colorado State. Oh, I'm talking about all.
Okay, we're continuing just with parabolas.
I got a site in Tennessee.
Again, parabolas, there's two equations that we're working towards. It's either the x being squared or the y being squared. If the x is squared, then your parabola is either opening up or down. If your y is squared, then your parabola is either opening left or right. Okay. You know that your focus is always inside your parabola, and your direction is always outside your parabola. Okay. So these problems are a little different because here you're given clues about the parabola, and you're supposed to piece it together and then gather enough information so they can write the equation. Okay. Rather than given the equation and finding characteristics, now you're given some characteristics and you're trying to work backwards down up to the to gain the equation. Okay, but we're going to be able to kind of sketch things out and be able to use that to help us out. All right, so vertex is -5, 1, and focus is -1, 1. Go ahead and plot those points. So if your vertex is to the left of your focus, how is the graph going to look? Opens to the what? To the right. Yeah. So if you know this, if you know how it opens, you know which equation that you're working towards. So we know this parabola opens right. And let's just go ahead and put the equation that we're trying to target, right? We know that we're trying to create an equation that has the y being squared. Now, if you count the distance between vertex and focus, what information do you get? What's that distance called? What did we discover yesterday when we counted? That's a p-value, right? You know from your vertex you can count a distance to get to your focus, and then count the other direction to get to your your directrix, and you know that distance from the vertex to the focus is going to be your p-value, right? So what's our p-value here? 1, 2, 3, 4, right? 4. You know your vertex is -5, 1. You can label that as your HK. So I think we have enough to build our equation, right? All we need is the vertex and the p-value, and we can go ahead and put that equation. So let's go ahead and see if we can get our equation written out. I think 4 and 4 gives us 16, and we can combine the two negatives to become positive. Okay. You know that your focus is inside the parabola. You know your directrix is outside. If you have the p-value, you can just count backwards, same distance to get to your directrix, right? Or to get to a point that you can help create your directrix. So 1, 2, 3, 4. What's the equation of this line here? Yeah, x equals -9. Yeah, any vertical line has an equation of x equals. Okay. You know, if you create a line that cuts through all 3 points that you graphed, you know that's going to be your axis of symmetry. That's going to split your parabola in half. Now that we have our equation built, what's our focal width? 16. You know you're always going to, from the focus, you're always going to count half that distance, right? You go up 8 and down 8. Okay, number 2, see if we can put all that information on the graph, and from there decide which formula, which variation of the parabola formula will you try to target. Okay. So give that a try, and I'll follow up with the steps. Axis of symmetry is y equals 2. Focus is 0, 2. P is -3. Okay, how is this graph going to open? Yeah, to the left. Your p value is -3, so that's also telling you that it's going to be either down or left, but the axis is splitting the parabola in half, so it has to look like opening to the left. Okay, so we know what equation that we're trying to target. So you know your parabola looks like this, right? Your focus is inside, your vertex is to the right, and then your directrix is further to the right as well. So if I know the focus and I want to try to reach the vertex and directrix, I'm going to continue moving to the right. So that p-value tells me how many units to go over. Find your vertex. That's your HK. And you can start inserting into your equation, right? You have your vertex, you have your p-value. That's all you need to get your equation written out. Do a little bit of cleanup. Okay, directrix, x equals 6. What's the focal width? Yeah, this number in front of that coefficient, or in front of the parentheses.
So
Yeah.
Where do you get the -3 from the H? For x -3.
Oh, the vertex was 3, 2. I counted from my focus. My focus is 0, 2. I know because my p is -3, I have to go to the right to get to my vertex. Okay, number 1 under the practice is a little different. So I want to make sure that that you guys have a chance to try number 2 before because I want to go over this problem. This is a little bit different in terms of how we set this up. Okay, does anybody still have any questions so far? Okay, so let's look at number 1 here. Thank you. Okay, so it passes through point -3, 1, and the vertex is -2, -3. So -2, -3. Okay, it tells us which way it opens. It's opening to the left. So you know your graph is going to look like this. But the issue is that this point is not a special point. It's just a random point that sits on the graph. So it's not going to help us get to the p-value. It's not going to help us get to the focus. It's not going to help us get to the directrix. But there's still a way that we can move forward. So go ahead and plot that point. But you just know that this is a point that is, yeah, it's not a very, it's not a unique point. Now, so we know what formula to target, right? It's telling us it's opening left. So let's go ahead and write that equation down. Okay, so what are the variables associated with the vertex? H and K, okay, so now -3, 1 is not a special point in terms of characteristics, but it is still a point on the parabola. So what do you think we can replace? How can we use this with the equation? This can go in as what? Well, the vertex is H and K. This is a random point on the graph. What other variables do you see? X and Y. So it's not going to be permanent, but it will help us move through, because if I can fill in x, y, and hk, what does that allow us to do? Solve for p. So that's what's a little bit different here. We're not going to use the graph to get to the p-value. We're going to use the equation to get to the p-value. We have a random point. This random point is not going to be part of our equation, but it will help us solve for that p-value in the meantime. So that's what we're going to do. We're going to insert those 4 values into the equation to get to the p-value. Once we get to the p-value, then we can go back to the graph and we can get a lot more of our standard information that we're used to finding. Okay, so go ahead and replace y with 1. Replace k. Remember, everything we insert into the equation is going to be the opposite sign, right? Because of the minus here. Okay, we don't know what p is, but we're going to solve that once we get the rest of the variables filled in. X is -3. Yeah, +2. All right, let's see if we can get p by itself. But first, let's clean this up here. 1 + 3 is 4. 4 squared is 16. Okay, 4 times -1 is -4. I get 16 is equal to -4p. All right, so what can I do now to solve for p? Yeah, divide both sides by -4. Yeah. Okay, so now that you have your p-value and your vertex, we can now go back and write our standard equation. Okay. Now we're going to let the x and y go back to being variables. We just inserted them intermittently just to kind of get that p-value solved. Okay, so I have y + 3 squared equals -16, x + 2. And now everything becomes a lot more manageable or more familiar from previous problems, right? Fill out the rest now. Okay, you have your vertex. You know your p is going to be inside. It's going to allow you to find that vertex on the inside and the directrix on the outside. Oops, focal width is 16, right? 16 is the absolute value of that number you see in front. Positive 16. Focal width is 16, so you can count from the focus up and down 8 units. Okay, your bottom focal end of your focal width is going to be a little bit off the grid. Okay, your classwork are 2, 3, and 4, but I'll work through them as you guys are working through them as well. Okay, does anybody still need this page? Sorry, it feels a little bit off. Okay, let me just move that. Yeah, question? Guys, for those of you who are working ahead, which is fine, but just want to talk about number 4 real quick. We'll get to it. I'll show each of the steps, but for number 4, I should have given a graph that was better suited. So if you guys can cross off those numbers, and we're actually going to let the bottom corner be 0, 0. So we'll let the entire graph be the first quadrant. That will allow for us to create that, to match it with the word problem a little better. So for number 4, cross out those numbers. We're just going to make this graph entirely the first quadrant. So bottom corner will be 0, 0, and the arch will go here. Okay, we'll go through that. All right, number 2, focus is 3, 2. Distance from the focus to the vertex is 2 units, and the function as a minimum. So the function as a minimum, any idea how this graph is going to open? Open up, yeah. So this is the only graph that actually has a minimum, a physical minimum, a lowest y value. Negative infinity doesn't count as a minimum, so this is the only minimum physical point that we can identify. So we know this graph opens up. If the graph opens up, we know our equation will be x being squared. So if the graph opens up, you know the focus is going to be inside the parabola. So it says the focus to the vertex is 2 units. So where's the vertex going to be? Yeah, it's going to be down 2 units, right? 3, 0. The p-value is 2. That should be enough to get your equation built. Okay, number 3. Okay. In the searchlight, the bulb is placed at the focus of the parabolic mirror, causing the light rays from the bulb to bounce off the mirror as parallel rays. This provides a concentrated beam of light. Write the equation of the parabola of the focus, which is 3 feet from the vertex. Assume the vertex is at the origin, so you know the vertex is 0, 0. And the parabola opens to the right. Okay, so we're given a lot of help to start our equation here. Opens to the right, you know you're going to be targeting this y minus k squared formula. Hey, let's look at number 4 here. The arch in Freedom Park has a parabolic shape. Its height is 25 feet and its base is 30 feet wide. Find an equation which models the shape using x-axis to represent the ground. Use 1 square equals 2 feet and put the origin at the lower left corner of the graph. So we know the graph is gonna, we know that our arch is gonna resemble a parabola opening down. And I'm labeling everything, every tick mark, I'm thinking of it as 2 units. So I'm going to go to 30 to allow for that base. The arch is going to start at 0, 0, it's going to end at 30, 0, and the height will be halfway reaching 25 feet. So I know that between 0 and 30, my parabola is going to be split in half at 15. So I'm just going to draw that axis of symmetry right at 15. So it's going to be between lines here. Okay, the arch is going to start at 0, 0. It's going to end at 30, 0. And along the way, it's going to have to reach 25 feet right at the middle, at the center, right? So 25 feet. Okay, so you know your parabola is going to kind of open in this way here. Okay, so what's the order pair of the vertex? Okay, we'll let that be the HK. Now you may be tempted to think that this is the focus because we have identified points here, but we don't know what that focus is, but we do know a random point. We can either choose 0, 0 or 30, 0. 0, 0 is going to be the easier one to plug in, so we'll just let that 0, 0 be a point that we know for sure is going to be on this parabola. And we'll let that be the XY. Okay, so this is similar to that number 1 from the previous page where we're letting a random point to help us find that p-value. Okay, which formula are we targeting? Yeah, the x squared. Okay. Insert 0, 0 for x and y. Replace h and k with 15 and 25. Just make sure you change those signs. And we're trying to solve for p. Once we find the p-value, then we can fill out the rest of this these characteristics. Okay, 225 divided by negative 100 is negative 2.25 or negative 9/4. Okay, so we can insert and build our equation. We know our p-value, we know our vertex, and we know the equation that we're trying to fit in. And put this down here, and then once I clean it up, I'll put it into that equation. Four and negative 9/4 can reduce. The 4's cancel out. I'm just left with negative 9. Axis of symmetry. Okay, p-value is negative 2.25, so we basically have to take our y value and either add or subtract 2.25 to get to the focus and then to get to the directrix. So I know that my vertex is here. I got to move up to get to my directrix. Yes, question.
Wouldn't the K be
Oh, sorry. Yeah, sorry. Thanks.
it'd be Y?
Yeah, it'll be y. My bad. 5. Okay, thanks for that catch. Okay, so I know I'm at 25, so I'm going to add 2.25 to get to my focus, sorry, my directrix. Focus, I'm going to go down 2.25 units. So 25 minus 2.25. Focal width, 9 units, so we got to go 4.5 units on either side. All right, give you guys a few minutes. Let me come around and check pages 6 and 7. And then tomorrow we'll begin circles.
Maybe if I'm on another form, please.
Probably not with so many messy decimals. Yeah.